Very good morning, students. In today's class, I am going to discuss detection and estimation of halogens by quantitatively or qualitatively. As you know, the halogens are of important component of organic compound, except carbon and hydrogen. First, we discuss qualitative estimation and then quantitative estimation. The qualitative estimation of halogens conducted by following methods in case of organic compound, like as Beilstein test. First is Beilstein test. Beilstein test. However, this test is not reliable or confirmatory test of halogen because some other radicals are also give the test. But in this process, we use a copper wire. And make a loop at their end. This copper wire is heated in Bunsen burner till it seizes green color to the flame, and then this copper wire dip in the solution or compound of organic compound. Suppose it is the organic compound, then this copper wire till in this compound and then further heated in Bunsen flame. Then greenish layer or yellowish green, greenish layer or yellowish green layer impart to the flame, and it is the elementary test of halogens. It is the elementary test of halogen, because some other radicals or elements give this test also, but it is preliminary test of halogens. The chemistry of this test is when copper react with halogen, then they change into cupric halide, and they are covalent in nature. And we know that covalent compounds are volatile in nature, and they impart green color or bluish green color to the flame. Therefore, this test cannot given by fluoride ion, because copper fluoride, cupric fluoride are ionic compound, and we know that ionic compound have high melting point and boiling point and non-volatile. Okay, so this is the Beilstein test. Next, second test is Lassaignes extract test. Second is Lassaignes extract test. In previous class, I told to you how can prepare Lassaignes. Once repeat. Formation of Lassaignes extract. We take an ignition tube, then small pieces of sodium and add organic compound, red heat of the ignition tube, and then this tube put in the distilled water. Distilled water is pure water, does not contain any type of ion like as chloride, fluoride, because these ions are present in tap water. And after cooling room temperature, the filtrate is known as Lassaignes extract, and the residue remains in their test tube. This filtrate is known as Lassaignes extract. For the test of halogen, we take Lassaignes extract. In another test tube and added some drop of fuming HNO3, means concentrated HNO3, and further heating, and then added solution of silver nitrate. If white PPT appear by the addition of silver nitrate, then it is the confirmatory test of chloride ion. If pale yellow or light yellow PPT, then it is the test of bromide ion. And dark yellow PPT given by the addition of silver nitrate, then it is the confirmatory test of iodide. Lassaignes extract contain sodium halide and other organic compound contain carbon and nitrogen, therefore maybe sodium cyanide, maybe sodium sulfide, etc. By the use of fuming HNO3, other halide, other ions like as cyanide are changed into their volatile compound, hydrogen cyanide. H2S change into sodium sulfide, change into H2S. These are the volatile gas. Therefore, these radicals interfere the test of halides. And hence, to remove the cyanide, sulfide, etc., we use fuming HNO3, and then heating these change into their volatile compound. And this is the test of halogen. It is known as Lassaignes test of halogen. These precipitate, for example, AgCl white PPT is soluble in the solution of ammonium hydroxide or aqueous ammonia. It make complex completely soluble and make this complex. It is soluble. White PPT soluble. It also soluble in hypo, Na2S2O3, excess of hypo, and make another complex, Na3 AgS2O3 whole twice. It is also soluble, and this white PPT also soluble in sodium cyanide or silver cyanide and gives NaCN all twice. Both are soluble. Now, pale yellow PPT, it contains bromide ion. This AgBr is partially soluble in the aqueous solution of ammonia. Partially soluble, not completely soluble, because covalent character increase when increase the size of halogen. Therefore, AgBr silver bromide is more covalent than AgCl. AgI is more covalent than AgBr. Therefore, ammonia dissolve AgCl completely, AgBr partially, and AgI insoluble in solution of ammonia. However, this solution soluble in solution of hypo. Sodium thiosulfate is known as hypo. When we added hypo in excess, then it changed into the complex, and this complex dissolve AgBr, AgSO3 whole twice. This reaction used for the removal of silver bromide from the photographic film, and hence used in photography. Silver bromide removed by the use of hypo and change into the soluble compound. This light yellow PPT also soluble in sodium cyanide due to formation of complex also. Due to formation of soluble complex also. Now, similar test for dark yellow PPT of AgI. Dark yellow PPT of AgI. It is insoluble in ammonia or aqueous solution of ammonia. Completely insoluble, because it is more covalent than AgCl as well as AgBr. However, it is soluble in hypo as well as in cyanide, because make soluble complexes, and they are the strong field ligand also. And covalent compound, dissolve covalent solvent. In this compound, AgS2O3 whole twice and sodium. In some time, the question is arise, which donor atom of thiosulfate attached with silver? In this complex, the sulfur of this ligand, attached with silver, because sulfur is best donor site than oxygen, or according to covalent nature, easily polarized. Sulfur is larger in size and easily polarized with silver. Therefore, sulfur make covalent bond or coordinate bond with silver in this compound. It is important question. These are the test of halogen Test of halogen of qualitative analysis of from organic compound. Now another test of halogen is layer test. This layer test conduct for bromide as well as for iodide. We taken Lassaignes extract. Lassaignes extract of, in case of bromide, is contain NaBr, and then added chlorine water. A redox reaction takes place. In which bromide displaced from NaBr. To detect the liquid bromine, we added some covalent solvent like as carbon disulfide or maybe chloroform, maybe CCl4, etc. These are the covalent solvent, and according to like principle and in solvent extraction, bromine soluble in such type of solvent and make a orange red layer in the test tube. On shaking 2 or 3 minutes of this test tube, then orange red layer formed of the bromine in CCl4 or in chloroform, orange red layer. This is the layer test of bromide ion. Bromine is orange red in the solution. If excess of chlorine water is added, then yellowish layer is formed because chlorine and bromine make interhalogen compound, and this interhalogen compound is bromine chloride. It is yellowish in color. This is the layer test of bromide. Another layer test of chloride. Layer test of iodide ion. In case of iodide ion, Lassaignes extract. In case of iodide ion, Lassaignes extract contain NaI. Now we added chlorine water also. A redox reaction also takes place in which iodine is liberated by the chlorine. Redox reaction, displacement, non-metal displacement. To detect the iodine in this solution, we added some covalent solvent like as carbon disulfide, like as CCl4, or like as chloroform. According to like principle, covalent compound soluble in covalent or non-polar solvent. After shaking of the test tube for 2 or 3 minutes, then iodine make a violet layer in the bottom. Because solution of iodine have higher density. Violet layer in the solution. I2 in CCl4. Solution of iodine and bromine have higher density than water. The density of bromine water is nearly 3 gram per ml, and the solution density of iodine in CCl4 is nearly 1.6 gram per ml. Therefore, these are heavier than water and settle down in the bottom and make a layer with covalent solvent. And these are the qualitative test of halogen. Now we discuss quantitative estimation of halogen from organic compound. The method of quantitative estimation is Carius method. Carius method. In this method, we use a Carius tube. Carius tube is nothing, but it have a fixed weight. Carius tube is nothing and it have a fixed weight. Suppose the weight of Carius tube is W1, then we added some amount of organic compound, and then the final weight of Carius tube is W2. Therefore, weight of organic compound is W2 minus W1. we taken very small amount of organic compound. Therefore, we use Carius tube of the weight to find the actual weight of organic compound during the experiment. And in this experiment, organic compound treated with concentrated HNO3 and then added silver nitrate. Concentrate HNO3 added in this compound because some cyanide, sulfide, etc. escaped, and then added silver nitrate. Then we obtained precipitate, white PPT, AgCl, light yellow PPT, AgBr, and dark yellow PPT of AgI. Suppose this weight is W, and then we find percentage of organic compound in the mixture. Suppose we obtained W gram weight of AgCl. We know that 35.5 gram chlorine present in 143.5 gram of AgCl, because the mass of silver is 108 and chlorine 35.5. We know that 35.5 gram chlorine present in 143.5 gram of chlorine. Therefore, the chlorine present in W gram. Therefore, the chlorine present in W gram in this, and this chlorine comes from X gram weight of organic compound. X gram weight of organic compound. Therefore, the percentage of chlorine in organic compound calculated with help of this formula. This is the weight of AgCl, dry weight of AgCl. The X is the weight of organic compound in 200. Then find percentage of chlorine in this compound. Similarly, in case of AgBr, the weight of bromine is 80, and we know that 80 gram bromine present in 188 gram of AgCl. If the weight AgBr, if the weight of AgBr is W, then this is the amount of bromine. This bromine comes from X gram of organic compound, and hence the percentage of bromine calculated with help of this formula. In case of AgI, silver iodide, in case of AgI, the weight of silver is 108 and iodine is 127. Therefore, total weight is 235. In 235 gram of AgI, iodine is 127 gram. In 235, iodine is to 127. Is W1 in W weight the amount of iodine? This iodine comes from X gram of organic compound. Therefore, the percentage of iodine calculate in this formula, the percentage of iodine in organic compound. And these are the estimation, qualitative and quantitative of halogens. Okay, bye.